Good morning. Today we're going to be starting with talking about verifying solutions. So when we say verifying solutions, first let's kind of define what does it mean for us to have a solution. What are we talking about when it comes to a solution? So the solutions that we're talking about are solutions to equations. And we say that the solution of an equation is a number that results in a true statement when it's substituted in for the variable. When substituted in for the variable. So what do we mean by this? So let's just do a quick little example, just to kind of show this. So for example, consider 2x minus 5 equals x minus 2. Well, x equals 3 is a solution because 2 times 3 minus 5 equals 3 minus 2. If we go ahead and figure this out, this is 6 minus 5, 3 minus 2, this is 1 equals 1. And that's true. 1 equals 1. So we know that we have a solution. X equals 3 is a solution to the problem 2x minus 5 equals x minus 2. Now, these equations can sometimes be complicated, sometimes they can be very simple. And all that really matters when we're doing these is if we're balancing both sides of the equation. So let's look at something that's a little bit more of a chemical formula and see how, if these are correct, are they balanced, are they the same? So consider something like 2H2O2, and this converts to 2H2O, 2H2O plus O2. Well, we're going to see if these are balanced, if it's really balanced on both sides of this arrow here. So over here, we count the number that we have of each of our atoms. So here we have 2 hydrogens times 2, that's 4 H's. So on the left side we have 4H, and we have 4 O's. So if we look over here, we've got 2 times H2, which is another 4 H's. We've got 2 O's there, but then we also have 2 O's here. So we have 4 oxygen. So that makes sense. It's something that can work. That means that this is balanced on both sides. So if we were to say, how many hydrogen do you need on this side to make this? So if we had something like 2HXOX to 2H2O plus O2, you'd be able to find it out because we've balanced the equations. We've balanced the equations up here. We would know that here, x needs to equal 2, because you have 4H and 4O on this side. Now let's look at another little example. We're going to just check the solution, see if what we choose is a possible solution. So let's go ahead and say, well, 2x sorry, 2 minus 3x equals -7. That's what I wanted to use. And the question is x equals 3 a solution? So all we do is we plug in 3 into this. So we'll say 2 minus 3 times 3. And we say, okay, well, this is 2 minus 9. 3 times 3 is 9. Well, 2 minus 9 is -7, so -7 equals -7. So x3 is a solution. 3 is a solution. And we're good. Let's do another example. So suppose we had something like 14 over x minus 1 minus 4 equals 10. And we're going to test x equals 2. Let's go ahead and test x equals 2. So here we say, all right, well, we'll plug in 2 on the bottom. So we get 14 over 2 minus 1 minus 4. 2 minus 1 is just 1. So this is 14 over 1 minus 4. 14 over 1 is just 14. So that's 14 minus 4, which equals 10. And this whole time we're just trying to say, does this equal 10? Well, yes, it does. 10 equals 10. We're good. So what do you do when you get a solution, or when you're given a possible solution, you need to check if it's right or not. So let's look at that same problem that we just did, and we're going to put in an incorrect solution. We're going to test x equals 1. -1. Let's test x equals -1. So then we get 14 over -1 minus 1 minus 4. -1 minus 1 is -2. So this is 14 over -2 minus 4. This simplifies to -7. -7 minus 4. Well, -7 minus 4 is -11. So this is -11, and this does not equal 10. This is a false solution. It does not work. So we know if we get a solution, there's possible that we won't get a correct value if we just plug in a number. So let's go ahead and look at another example. So let's consider something like x squared equals 5x plus 24. Now, if we wanted to find solutions to this, we could make a table like this. If we look at this and we're trying to find some sort of solution using this type of table, we could. So here, what I'm using right now, this book is the math literature book. We're using it for our class. So I'm just pulling this out of the textbook that we're using for our class. From it's a Pearson book. If you look over here, we have the different values for x, and it says what's on the left side And it says what's on the right side. The left side is our x squared, the right side is 5x plus 24. If you look here and it says use the following table to identify the solution or solutions to the equation x squared equals 5x plus 24. Well, when we look through here, we got to find out which ones have the same thing on the left side and the right side. So looking here, we have 16 on the left side and 4 on the right side. So we know that's not a solution. When x is negative 3, we have 9 and 9. They're both the same, the left side and the right side. So we know that those x equals negative 3 is a solution. As we go down the rest of here of this, we see that it doesn't match up again until we get to x equals 8. When x equals 8, we have 64 on the left and 64 on the right. So that shows that our two solutions are negative 3 and 8. So that's going to be it for verifying solutions for the lesson part. If you wanted to do any practice on your own, you can go ahead and practice with 3x minus 7 equals negative 5 times x plus 3, and check is x equal negative 1 a solution. And then you can also check 2x squared equals 4x minus 3 halves. Is x equal 3 half a solution? So go ahead and do those on your own, and you can leave your answers in the comments. Have a good day.